Hey there, I'm Greg, and welcome to my channel, Midnight Oil Software, and another Unity game development tutorial video. This is the 5th video in my Ninja Egg series, and in this video I'm going to show you how you can calculate and display the projected trajectory of a projectile. If you've ever played Angry Birds, you probably noticed that when you grab the bird and drag it back, it shows the projected trajectory that the bird's going to take when you let it go. And I'll give you a quick example of that. Here, you'll notice here that it's showing this projected trajectory that the bird's going to fly when they let go of the bird. And they also tend to show trail renderer particles too, to show where it went. And there it goes again. So in my Ninja Eggs game, which is essentially an Angry Birds clone, I wanted to do the same thing. I wanted to be able to show the trajectory that the egg would take when you let it go. Now, my Ninja Eggs game was inspired really by Jason Wyman's stream, where he showed you how to make an Angry Birds clone from scratch. And he did a really good job of whipping this game up in just a few hours in front of a live streaming audience. And in his game, he didn't show the projected trajectory that the bird would take, but what he did do is he used a line renderer that would just show the angle that the bird would launch at. And I'll show you an example of that here. So he grabs the bird, and then he uses a line renderer with a start point and an end point. So he only has 2 points, and it shows points along that line. And it shows the angle that the bird's going to take, but it doesn't show the full trajectory of the bird. It doesn't take into account the force that's applied or the gravity, that sort of thing. So, and by the way, I'm not in any way disparaging Jason or his game or his tutorial. Jason's awesome, and his tutorial is amazing. In fact, his channel, if you haven't checked out his channel, you really need to, and I've learned a ton from him. But this, for what it is, was awesome, but even Jason encouraged us to take this project and develop it further. So that's basically what I'm doing. I'm going to take his initial concept and I'm just going to develop it further by, instead of just showing a start and end point for the bird, I'm going to show the full projected trajectory that the egg will take when I launch it. And to do that, I'm going to use an algorithm that I got off of this page here. And I'll put a link to this in the description of the video so you can go check it out. It's not a super complex formula. And one thing I like about this page here is it gives you code that shows you how to implement this in your game. And so I'll take you to my game and I'll show you basically how I implemented this. Click play here. And we'll go to the first scene. Now, when I grab the egg and I drag him back, you can see that it's showing the trajectory that the egg's going to take when I let him go. And the farther I pull him back, the more force will be applied. So if I barely drag him back at all, almost no force is applied. You can see that he hardly moves. And this is really useful to help you if you want to accurately drop the egg on top of a target or something. So here I'm just going to pull him back as far as I can and let him fly. And you can see that he accurately flies over the plot that was shown there, which is really helpful, especially I'll show you on the 3rd level why that is particularly useful. Well, and this would be a good example here. I want to drop the egg right on top of this guy here. So then that shows me exactly still didn't get him, but that shows me exactly where the egg's going to go. And that guy is just hard to get. Boom, got him. So where it really comes in handy, though, is on a level like this 3rd one here, where I want to sneak the egg in between, some obstacles here. And I want them to bounce along the top of these guys over there. So that's a good example of where this comes in handy. Also, I want to hit this boulder up here and send it rolling and still fall backward and hit the guy behind me. So that's where this projected trajectory really comes in handy. So how do I do that? Well, like Jason, I use a line renderer. And so let me go into my scripts here. And I had this class called Launch Trajectory. So we'll go ahead and open up Visual Studio here. And this class is not super complicated. I'm going to grab the line renderer, and you'll see where I have it defined. I'll show you in the inspector that basically has 20 points. And this is the function here that does all the work. This calculate projected trajectory. And what I'm basically going to do is I'm going to iterate 90 times through this loop. And every fifth iteration, I'm going to save off the calculated point. And so each iteration through, I'm taking its current position, and I'm going to apply the formula that I showed you on that web page, where I'm going to take the amount of force and the direction and the mass. I'm calculating all this stuff to get the velocity that's being applied. I'm going to multiply that by delta time, and I'm going to apply it to the position. And then every fifth iteration through, I'm going to take that position and save it off in this collection of points. And then when I'm all done, I just convert that to an array, and I call the line renderer set positions. And that tells the line renderer all the points along the line that I want it to plot. So not super complicated. We'll go back into the game and we'll click play. And you'll see when we switch over to we'll go to the first scene. And you're going to see that it's added this launch trajectory component. And in the launch trajectory, I've got this positions collection. And I actually lied in the early part of the video. I said I had 20 points. I'm actually doing 50 points along the line. Okay, so watch when I grab the egg and I drag him. You can see that it's filling in all those points with the positions along its projected flight path using that formula that I showed you from the web page. So that's pretty much all there is to it. This is just a component that has a line renderer and this collection of positions that gets applied to the line renderer using the points that I calculate. So hopefully that's something that you'll be able to utilize in your games if you ever want to calculate the projected trajectory of something, if you want to like lob a missile at somebody or something like that. And if you do find it useful, please click the like button, the subscribe button, and click the little notification bell so you can always see when I post another video. And if you have any questions or comments, or if there's anything in particular you'd like me to address in a future video, just leave a comment down below, and I'll respond to that as soon as I can. Once again, thank you so much for watching, and I hope you have a great day.